2013 Russell DeSouza Award for outstanding service to the Unidata community. And to kick things off, we'll have Mohan introduce.
Thanks, Kevin. This is always a highlight of our governing committee meetings and activities every year, and that is to recognize individuals in the Unidata community who have made outstanding contribution. Ever since the beginning of the Unidata program, Unidata has benefited greatly from the many contributions our community members make. You all make Unidata great. It's not just the activities of the program center. And we instituted this Russell DeSouza Award in 2000 to commemorate Russ DeSouza, who personified the spirit of this community contribution. Russ DeSouza was first a users committee member and then a policy committee member from Millersville University, who transformed Unidata in so many ways by his many contributions. And you all can see the benefits of these many contributions and how Millersville has taken on as one of the flagship undergraduate and master's degree programs in meteorology. This particular award in his honor essentially is to honor individuals whose energy, expertise, and active involvement enable the Unidata program to better serve geoscience. Honorees personify Unidata's ideal of a community that shares data and software through computing and networking technology. And it is indeed my pleasure to start the proceedings here and turn it over to Kevin to recognize this year's awardee, Larry Oolman from University of Wyoming, for his outstanding contributions. Kevin will have further things to say. Congratulations.
Thank you.
Thanks, Mohan. Again, very pleased to present this award to Larry, and I'll just read some of the citations that the committee that chose Larry for this year's award came up with. As we stated, Larry, your early and ongoing work in making observational data available to the broad atmospheric science community has been invaluable for countless students, teachers, and researchers around the world. And for many, it is the go-to site for especially your archive of soundings on the Wyoming web server. I can tell you, on our Friday afternoon map discussions at UAlbany that Lance Bosar presides over, it is the very rare week that goes by where we do not visit your site to download some and explore some soundings from either real-time or past cases. And this really exemplifies the outreach that this award commemorates. You demonstrated sustained commitment to this important resource without fanfare, and we're going to give you a little fanfare now, but Unidata community wishes to acknowledge your contribution, and as well as in terms of your efforts towards contributing to the standardization of aircraft archive data formats. For those who don't know, Larry is a pilot and has
Not a pilot.
Not
a pilot.
But you're on the Wyoming King Air
A lot.
quite a bit, and so your work on the aircraft archive data formats and on the Unidata NCAR Research Aviation Facility NIMBUS conventions for NetCDF, these types of efforts have led the effort towards standardizing data formats. And so for your dedication, enthusiasm, and inspiration that truly reflect the goals and ideals of the Unidata program, I'm very pleased to present to you the 2013 Russell DeSouza Award. Congratulations.
Thank you.
And now Larry will, as part of the tradition, the award recipient will present a presentation illustrating how he's used Unidata software and tools over his career.
Okay, entitled this Thinking Outside of the Unidata Box. University of Wyoming is a fairly small department, research-only department, but one of our strengths is we have some really fun toys up there, and we take observations. The biggest thing I work on is our research King Air, and taking the observations with this presents some unique challenges that have sort of sustained us through the years. Interestingly, I am the second University of Wyoming graduate to receive the DeSouza Award. Number one was Rich Clark, who has been very instrumental in the whole Unidata program. But he and I attended school together at the University of Wyoming many years ago. Long enough ago that Tom Yaxis was still there.
And Rich Clark was a colleague of Russ DeSouza at University.
Yes.
And Russ was the department head at one time.
So a little introduction to myself. I'm one of the project managers for the Wyoming King Air, and so if a plane goes out in the field, chances are I'm there half the time. We have another individual, Jeff French, who's the other project manager. I also am the head of IT in the atmospheric science department at Wyoming, and so sort of the two of them together keep me busy. My entire staff is Tom's replacement, a gentleman by the name of Jim Waldron. And here today also is my wife, Chris. She's been very supportive, patient, and great about my absences from Wyoming on field projects and the time I've spent trying to get things working at the department. So as I mentioned, we're a small research-oriented department, 10 faculty and roughly 20 graduate students. And our strength is in instrumentation and measuring the atmosphere. One of our newest faculty members is Xiaohong Liu, who was named the Wyoming Excellence Chair in Climate Sciences. He'll be taking, his expertise is taking aerosol, cloud interactions, and has written major portions of the code that go into the community climate model. And we're excited to have him on board and to work with him to further refine what aerosol data he needs for the climate model. A few other UW graduates. I mentioned Tom Yaxis. Formerly next door, Tim Spangler and Wendy Abshire, both graduates from Wyoming. And an individual who did not get a degree in atmospheric science, but is worth talking about a little bit, is a meteorologist, owns his own company up in Cheyenne. His name is Don Day. And he was the meteorology for the Red Bull Stratus high altitude jump about this time last year. Came to Wyoming interested in broadcast news, and his advisor told him they should really take a weather course. And from that point on, I mean, weather has been his passion. He took pretty much all the, as an undergraduate, took all the courses that he could take in the department. And we had a project back when, an era where funding was slim, is we brought over about 150 Saudi Arabian students to learn meteorology. At that time, not only was funding tight in the U.S., but the Saudi Arabian government was tightening up a little bit and decided that they should have some of their own people working in the weather service rather than expatriates. And so we taught meteorology not as part of the university, but a separate training program. And Don, as an undergraduate student, taught quite a number of our weather courses. I'll take the credit that I taught him a class we had back then of weather briefings where we give forecasts. I probably didn't teach Don anything, but I sure learned a lot from the guy. So he sort of switched his focus from broadcast news to wanting to become a weather forecaster. This is prior to the Weather Service reorganization of the 90s, and he had a job lined up in Sheridan, Wyoming as a forecaster. And one of the reasons I put him in this presentation is many of you that are maybe my age have heard of the Graham-Rudman Holdings Act. This was one of the early draconian cuts in the federal government, and his job was frozen, and they said it'd likely be 18 months before that position opened up, and then when it happened, he'd have to reapply for it. Well, a young kid fresh out of undergraduate school probably can't sit around for 18 months, and so he borrowed some money, started his own meteorology company in Cheyenne, Wyoming, went around to the radio stations and told them, I'll give you weather forecasts free, it'll cost you nothing. The only thing is I want to be able to sell a 30-second spot on each of my forecasts. And so their own marketing people didn't even have to find advertising to pay for anything. Is he went out and went around and found advertisers and made a very successful business out of that. Unfortunately, they at that time had already had meteorology services from one of the big companies in the US, and they didn't care for it too much, but he holds quite a market now. If you look at the videos from the Red Bull Stratus jump, Don Day is sitting in the second row watching this jump, and he's an avid balloonist himself, and so to have a qualified meteorologist interested in ballooning, he's sort of created another niche for himself. So I mentioned some of the toys we have up in Wyoming. This is the talk I give whenever I can talk to undergraduates is, come to Wyoming for graduate school. We have the most fun. So our premier picture here is of our King Air. You can see it's not very big, twin engine, turboprop. This picture was taken in Iceland on one of our ferries across the ocean to Europe in the last few years. This little appendage here is where there's an antenna for our cloud radar, which, that's not the radar. Where'd the radar go? Well, I don't have a picture of the data, but here's what the radar looks like sitting in back of the NSF NCAR C-130. Has a resolution of about 7.5 meters. It's a W-band radar operating at 90 gigahertz. The King Air, a number of years ago, about the time we had the funding crisis that we taught Saudi Arabian students, we submitted a proposal to the National Science Foundation to make it a national facility. And so I think we've been doing that for over 20 years now. Which that means is that any of you can write a proposal to go out and study the weather to the National Science Foundation, say, oh yeah, to do my research, I need the King Air or the C-130 or the Hyper Gulfstream 5 high distance, fast, long distance plane. And they will provide the money for it and the staff for it out of a separate budget, a deployment budget. It doesn't cost your proposal anything. So this picture here, we also, besides the radar, have a cloud LiDAR, which is even higher frequency than the microwave radar. And here's an image. You can see where the cloud tops are in here. The areas that are kind of broad there are probably ice particles in the top of the cloud. The areas where it doesn't have any attenuation in there, but there's areas where it attenuates very rapidly, and you can. So we were able to differentiate between ice and water before the aircraft, below the aircraft, or above it for that matter, but we usually try not to fly below supercooling. The professor at Wyoming who developed this came to Wyoming. He was a student of Ken Sassen's at Utah, which ironically, Ken Sassen's a graduate of Wyoming, and so it's sort of come full circle of producing observationalists that come back to Wyoming. Another facility we have is the Elk Mountain Observatory. There's a mountain that sort of sticks out at the end of the snowy range up in Wyoming, isolated peak. And in the wintertime, it's covered in cap cloud about 1/3 of the time. And so even before Wyoming had aircraft, we were up in the clouds measuring things. And we were looking at, this is back in the 60s, what is in wintertime clouds? Is there super cool water? what types of particles. The same questions we're asking today, but we did it from an in situ observatory. Another long-time facility at Wyoming is our ballooning facility. They just celebrated a few weeks ago the 50th anniversary of having a ballooning facility at Wyoming. It started out in the physics department, and after some key people left, it was transferred to the atmospheric science department. Also has one of the longest running records of aerosol measurements of any site. They were down in Antarctica for a number of years prior to the ozone hole being discovered. And since they're already down there, they added ozone sondes to their aerosol package and made some of the earliest in situ measurements of the ozone hole. And it's currently under the direction of Terry Deschler. Another toy add to ours is the NCAR Wyoming supercomputer. Is when NCAR outgrew the Mesa lab for power and space for their supercomputing needs, Wyoming heard of it and made them an offer that they couldn't refuse. And so now Wyoming owns a 20% stake in the supercomputer, which probably makes the Wyoming share one of the larger supercomputers available to a university. This is one of the reasons that we're able to get Xiaohong is that he is using the supercomputer at NCAR to do the climate studies. And finally, the picture on the top here is a couple of our research scientists doing air quality measurements. In the last number of years, the gas fields were discovered in Wyoming, in both around Wamsutter and Pinedale, Wyoming, and just an explosion in the amount of gas. I can't believe how cheap it is to heat my house, to be honest with you, is that they produce more gas out of these fields than they can pipe out of Wyoming, and so the prices up there are quite cheap. And so before we started doing monitoring, hardly anyone started doing monitoring, there was concerns about ozone in these basins. Of course, ozone is a photochemical process, and so they had a requirement that they had to monitor ozone in the summertime when the sun was high. Well, someone forgot to turn off the monitor, which for the gas industry was a bit of a mistake because it was running all winter, and all of a sudden they found ozone levels that exceeded EPA standards. The ozone in these remote Wyoming basins was higher than Los Angeles. And so they put out a $500,000 study, hired some private company to give them an answer that they could live with. They came up with the story that it has to be stratospheric intrusions. Turns out that having snow on the ground doubles the amount of ultraviolet light for these photochemical reactions. But so now we're into the air quality business. We have a couple research scientists that measure in Wyoming basins. We've hired a new faculty member that also does a similar thing. So there's a few things that we've done in the department. So here's some of the needs that it creates. I mentioned that we're a graduate-only department. I used to actually teach a couple graduate courses as duties were sort of shifted to the King era. I don't do it anymore, but a lot of the resources were developed to teach graduate classes. With our short campaign research projects and some of the air quality monitoring and things we do, we've had a need to be able to pull up and display short-term forecasts with products that are specific to our research. Also, the range on the King Air is not great. A lot of times the campaign is restricted to a particular geographic feature, a mountain range, a channel somewhere. And so we need to access fine resolution products in a nowcast mode. And so when we started, there just really wasn't a lot of that available. After these field campaigns, the professors, about half of our proposals actually come from Wyoming, need to access case study data. And and so we also wanted to be, in this case study mode, need to be able to superimpose the fine resolution observations from the aircraft or whatever instrument we have with things in a more regional context. And finally, involve students I've always found important. And I think it's one of the reasons why there is a good excuse to have a national facility at a university, is the focus is more on education than it might be at an independent lab. And so to achieve these things, as I mentioned, I have a very small staff. There's pretty much me. And so I can't write things from scratch. I just don't have enough time. And so having Unidata to at least provide the building blocks that I can extend have been able to produce things that have been useful to us. And so our involvement goes way back. You probably can't read most of this, but this was cut out of a 1990 UCAR corporate report. We had a professor back then, Gaber Valley, who was on one of the early policy committees. Matter of fact, except for Oklahoma, Wyoming has had as many people on user committee and policy committee as any other university, which I find amazing for such a small group up there. There have been quite a number that have had 3, though. So we borrow heavily. As much as possible, I use the NCAR Research Aviation Facility software. Mention data formats. I've worked with Chris Webster to refine their product, their NetCDF aircraft product, and use their software. Say as much as I can steal from someone else is a lot less stuff I have to write myself. And so our newest data system, we used to completely build our data systems from the ground up, write all the code that run it back then in assembly language, and now we've gone to sort of the tact of buy, beg, and steal as much as we can. So we've gone to National Instruments LabVIEW to develop our data systems. So going back to sort of a summary of what this fine print is, that back in 1989, 1990, somewhere in there, I forget which, 1989, we took the King Air to Saudi Arabia to study cloud seeding potential over southwest Saudi Arabia. Of course, you want data products there. Where are you going to get those? And so we purchased a high-speed modem, 9600 baud. Got a connection to SSEC in Wisconsin, and we're able to download Mediasat images across the modem to Saudi Arabia on a limited area that they produced for us. Also, about the same time as when we had the Saudi Arabian training program, we needed data from that region of the world. I mean, you could teach them meteorology from the mid-latitudes, but it'd do them much more good to look at data products from their region. And so that's about the time I became involved in here. As a matter of fact, I think my name is actually mentioned in this report of producing products, international data to support things going on in the department. As a result of this, somewhere there's a Unidata newsletter that has my picture in there with one of the Saudi Arabian students. That picture was used at the Mesa for quite a few years in a display life-size picture of me. It was kind of scary to walk in and see it, talking about outreach and use of Unidata. 1990 was also when the original Desert Storm was, and all of a sudden all these observations that I had over Saudi Arabia disappeared as they were no longer part of the international feed. The Scud missiles that were being used, if they had wind data, they could target them more accurately, and so they didn't want any of that to go out. And so it was kind of a stressful time for the students to essentially at home involved in a war while they were over here, and we had to sort of adjust our teaching to be able to teach them without the real-time data. All this was happening pre-internet. The computer they took over there, I think, was an IBS PS2 Model 70. It probably had a 386DX CPU, math coprocessor, a whopping 8 megabytes of memory, ran at 12 megahertz, had a 3.5-inch floppy drive. Many of you probably have never seen a floppy drive. This was sort of a part of our original reconfiguration also for the McIDAS data satellite feed that many universities had. And in the department, it ran OS2, which was another thing no one's ever heard of anymore. Wonderful operating system. Microsoft was a full partner in there until they decided they could probably make more money going on their own and dissolve their relationship with IBM. But OS2 was early, didn't have network features, and so once per hour the signal would come across the McIDAS data feed to reboot the computer. It would boot up into DOS, transfer the data you wanted to a server, and then reboot itself back into OS2 to receive more products. And you had about a 5-minute window to get those data. Tom's laughing over there. He remembers it well.
This is the good old days.
Incidentally, I retired my last OS2 computer in December. And the only reason it was connected to a Campbell data logger, and all it did was would go out there and grab some things recorded on the data logger and transfer it to a server. And we remodeled our classroom, so the computer had to go. So that's our early days of how I got involved in Unidata. Talks about another story of how I carried it even further. This is a Google Earth presentation of some balloon trajectory forecasts that I calculate for our ballooning facility. And so it gets launched out here at the Laramie Airport. Have to report to the FAA where we expect it to be at 60,000 feet, which is above where aircraft fly. To report the burst point, and we have to have a pretty good idea where it's going to impact.
How high is it, please?
About 100,000 feet. That's what I put into the calculations anyway. So prior to this, we'd call up Lander radio sound station. There is no Lander anymore. Moved to Riverton, ask them where their burst point is. We have a pretty good idea where the balloon's going to drift, where it might impact, and we can decide that, no, we're not going to launch today because it's headed towards Denver, or we can launch because it's headed out to the panhandle of Nebraska, which, this one's still in Wyoming, I believe. And so one day Terry Deschler got ready to launch a balloon. You know this chain of events where when things go wrong, things go horribly wrong, and it takes a number of mistakes to get it that way? Well, we have a radio receiver that we can use to cut down the air that we normally use to cut down the balloon. And so it fires off, cuts the lines, and it's radio controlled. Well, the receiver they had is dual frequency, and we only have crystals in one of those sides of the receiver, and the switch got switched to the other, to channel 2. So we couldn't cut it down. And so as a fail-safe, we have 2 timers on there that after 3 hours, it cuts it down automatically. Well, so you program in 3 hours, set, start. Oops. Did everything except hit the start button. This is early in the GPS days. The GPS telemeter data was sort of a novel thing. It was a little heavier payload, and so since it was experimental, we didn't put the GPS on there. So this balloon takes off. We have no idea where it's going, where it is, or where it might come down. And so I get called in to figure this out, spend pretty much all night, thanks to my wife having a lot of patience for this sort of thing. Got about 2-3 hours sleep, came in the morning, asked whether it came down. The thought was that once nighttime happens, the balloon will cool sufficiently, this thing will come down on its own. Well, that didn't quite happen. But anyhow, I programmed some trajectory code took one of the numerical models and then had it grab and wrote my own trajectory program. At one point, it drifted over Denver Stapleton Airport, headed south to Colorado Springs to Cheyenne Mountain and the NORAD. Military, I think as an exercise as anything else, is scrambled the AWACS to try to track this thing. I've got a package that's this big, covered in aluminum foil. How could you not see the thing? They had trouble tracking it. But one time they got a fix. It was within 2 miles of where I predicted it should be. Deschler was a convert. Figured we don't need Lander, Riverton anymore. We'll just write this code to project it where it's going to go. And in general, it's within about 10 to 15 miles of where I say it. I'm just using GFS data. And so even though the GFS forecasts might be horribly bad, it's mostly upper level winds, and it does a very good job at that. So, in-house product, put it on the web because we go to Antarctica every year and they need to get this. We went to Kiruna, Sweden, Niger in Africa, South America. So the best way to disseminate the information is across the web interface. Again, a lot of fine print here, but a group of students from MIT came up with a way and published it of schools could send up a balloon, take pictures of space for about $300. It became an instant hit. The catch is you still don't want to lose your package. You like to recover your camera and stuff, so where do you figure out? And so in the article, they published where you can get balloon trajectory forecast. And so I probably get 1 or 2 emails a month from schools wanting to know about the program, how it's written, what data is available, and that sort of thing. So another example of things I did internally for my use or department use that went viral. Okay, another King Air story is back in 1992. So shortly after the Saudi Arabian project, we were involved in a project called Stormfest. It was looking at winter storms over the Midwest. Another great example of how to do weather modification. At one point, I think the 500 millibar temperatures between International Falls and Brownsville was about 5 degrees difference. Not a lot of winter fronts out there. But we did come across one good case, and NCAR at that time was writing these wonderful software to consolidate different data sets and stuff, but again, it didn't have things specific to what we needed. So we go fly for 3-4 hours in some really, really nasty weather, find the only airport that's open to refuel because of fog, and that was in Tulsa, Oklahoma. It's nighttime, the pilot's getting tired, all of us have been rattled around in the airplane for an hour, and look at this little report coming out of Kansas City about freezing rain. And we're sitting there going, really? And so they had an operations center that I call a double blind test. These guys had a windowless trailer that sat inside of a windowless hangar. Call them up, freezing rain? No, there's no freezing rain. Don't know what that report is, no problem. I scraped an inch of no problem off my windshield with a credit card when I got back. So again, the operations center was incapable of providing us the data because they didn't have the tools, and so I provided a hookup that they could actually obtain text METARs, or actually back then it was the SAs, to give us a point observation repeated. They had no way of retrieving that data. So again, tailoring specific, very specific products to things we needed to operate safely. And so skip ahead a few years, IDV. I don't know if any of you know Vanda Grubasek. She's now the head of EOL. But she had a project 2006 out in the Sierra Nevada looking at rotors coming off of the Sierra Nevada, which is Mount Whitney to Death Valley. Huge change of elevation in a short amount of time. And so EOL at that time was looking at integrating IDV, replacing Zeb or Zebra or whatever they called the previous software. And so here's a plot that I think she produced. of the plotting King Air track with IDV, and so we'd start high and step down, and then finally here's the mountain range, so the Sierra Nevada and the White Mountains. And plot on the left is turbulence level from the King Air. The plot on the right is vertical velocities, and so I think she reversed this. See, how does this go now? Reds are downdrafts and blues are updrafts, and so you can see as you get close to the mountains, there's downdraft, updraft, and well, here's a good, you can see the wave pattern, down, up. So that down didn't show up much, another up, and so you get into these mountain waves. And so there's a scale here on the turbulence. It's from the probe we have on the aircraft that I call the fun meter. It goes from 0 to 10. Sometimes I've seen 14s on there. So 0 to 3 I'd call light turbulence. About 3 to 4 to maybe about 7 or 8 would be moderate. And as you get into the reds is what I would call severe turbulence. It's at that point you can no longer focus on the computer screen in front of you. And so we go down nice and smooth, hit mountaintop level, and things get quite bumpy. One of the highlights of this project is this experiment had been done back in the 1950s. One of the lead people is a gentleman by the name of Kutner. They didn't use motorized aircraft. They used sailplanes to study mountain rotors. I mean, it's a prime sailplane capital mecca. I mean, you get these huge mountain waves and you get up to 40,000 feet with a sailplane. Kutner back then was still alive. He's 95 at this point, and went up for one of the research missions. And I just thought that was absolutely the coolest thing ever, is this 95-year-old gentleman still doing atmospheric research.
He worked here upstairs until he was 99.
Yeah,
And then
remarkable gentleman. And still sharp. I mean, working on this project, he would sometimes make statements that were contrary to things Vonda made, and he was usually right.
he actually his first sailplane in the 20s
Yeah.
in Germany.
So the use of IDV about the same time, we're going, hey, this is cool. Unidata actually did work to be able to import this RAF Nimbus style files and to make it general enough that it could read minor differences between the way NCAR produced them and Wyoming produced them. And so Bart Gertz, who is now on the user committee, who couldn't be here today, did a project out of Tucson around Mount Lemmon. They were looking at the initiation of convection on the mountain, interested in convergence in the low parts of the mountains, and so he and one of his grad students produced this figure with IDV. Shows again the flight track, wind barbs from the King Air. I think the colors are theta, and so you can see where there might be warmer sides of the mountains, or where you could get convection starting, but you get to cooler temperatures, so there's a little bit of stability as you get higher. And so it was a great example of being able to merge the high resolution King Air with, in this case I don't have anything overlaid, but we could overlay the NextRad or other products over it. We were also at this point just getting started with a satellite modem, and we were telemetering data to the ground at that time, importing it into a netCDF file that they could use IDV on the ground to also look at the data. And so another example of a specialized data set that I was able to produce with GEMPAC is last summer again for Bart Gertz. We had a field project flying over the Medicine Bow Mountains, and as part of a weather modification program that's going on in Wyoming, the state allocated like $8 million to study whether weather modification worked or not. And this was in an experimental mode, not as most states do, is hire someone, just go out and do it until it works. They hired WMI out of North Dakota to do the cloud seeding, but the other half the contract went to NCAR to evaluate whether the seeding is working. So Bart, as part of this, wrote a proposal on National Science Foundation to go up, and I mentioned we have these remote sensing instruments now, the radar and the LiDAR, that can look down and tell whether there's supercooled water or not, which is something that we couldn't do back in the 70s and 80s when we were originally studying weather modification, because you just didn't want to fly that low in mountains in the wintertime with downdrafts. And so one of the products I produced for Bart is they had a number of criteria for when they could seed. One of them was the temperature at 700 millibars had to be colder than -7. So I put on here a heavy contour of -5. This is a time height cross section with a time series. They're interested in supercooled water. This uses the NAM 12 kilometers. One of the products in there is supercooled water, so I was able to plot that, precipitation rate, upper level temperatures, winds, relative humidity. Just integrate everything, click a quick summary in a couple minutes to be able to tell whether we can likely go fly or not. And so here it's snowing, no supercooled water. The temperature is close to what the minimum was. Later on, as we get to the warmer colors here, we have in here we have a dry area come in, and a re-emergence, and in that early part where we can see there's potential for seeding. And it proved to be so useful that WMI wanted access to that product. So as I mentioned, one of the important things of working in an academic institution rather than a research facility is the emphasis on students. So here's some pictures of students that have flown over the years. This one here was taken, this is Dave Rogers, another Wyoming graduate, Dave's retired now, I believe, from NCAR. This is on the plows project, Bob Rauber, University of Illinois. Had a whole C-130, very minimal instrumentation, so there was a group of us in the back row running the radar, the LiDAR, dropson, and a student from Clarkson University that had his own little piggyback project on it. And the rest of the airplane was empty, a big empty C-130, and so Robert, being an educator, decided to fill it with students. And so we had lots of students flying around, and we'd get up and talk to them and explain things to them. It was fun. Prior to the two triennial workshops, we had a student program with NCAR to study observations. And so we're using the King Air and put students in the front seat, design the whole research mission. And so her mission one day was to come up and study essentially convective initiation. So we're near Cheyenne, flying around, small little towers popping up, and they just didn't go anywhere. They'd pop and collapse immediately. Of course, looking to the north, this is a picture of the Vocals 2 storm. The one they chased storms all year, were never able to until they were up in east central Wyoming. And here's a picture from the King Air. We just happened to be flying around one day with students. I didn't really want to go over there and fly through that. And so I mentioned going with the National Instruments new data system. This happened in 2009. And as electronics miniaturize, it provides more space for other things. And with the King Air, usually that other thing is we can add more instrumentation. This last go around, what we added instead was a fourth seat. And nominally it's supposed to help me run all these instruments because I'm pretty much overwhelmed with trying to keep on top of whether everything's working. But a lot of times we provide space for students to go up and have an experience. And so for the spring workshop, I counted up, when I put this together, I had 40 students in the King Air in the previous 5 years, or since 2009 when we implemented this new data system. And so it's been a great teaching laboratory, I find. And so one of the upcoming deployments we have, we're going down to Embry-Riddle University down in Prescott this spring. Melanie Wetzel used to work at DRI, is now at Embry-Riddle, and we're going to spend 2 weeks letting the students design experiments and going out and executing them with the King Air. And so I'm looking forward to that. And so here's a base map that many of you probably recognize. This is on my weather servers. By the way, if you're concerned about the speed on that, I actually have the hardware in shop now. The disks are probably being installed today, and so I'll be having a new weather server here shortly. I'll have to recompile everything for 64 bits, but it's a small price. The current server, I think, was bought in 2001 or 2002, and so it's an antique. I claim that this server is primarily a hobby. It's a little more than that, but I wrote it, a lot of this products for my own personal use, for teaching I was doing at the time, or requests in the department, and for research. I've gone through the logs, received somewhere between 130 and 500,000 requests for data. This isn't hits for every little ancillary graphic. These are actually, it goes out to the CGI and says, I want this product. So it's between 130 and 500,000 a day. 2 to 4 terabytes of products given back from somewhere around 2,500 distinct IP addresses per day. Counted in a month from about 100 different countries. And so I went through the logs, and in April, some of the top domains is .net is 360,000 hits, .com 355, .edu 62,000. So I don't know what that means. .gov twice that at 123,000. So I mean it's being used by a lot of government institutions in the U.S. .mil military 20,000 hits. Or 20, our top domains, 20, wait, now I'm not sure what my notes mean, but .mil is 20,000, so the military uses it extensively. I've gotten emails from the USS Kitty Hawk, who's on maneuvers out in the Pacific, and all of a sudden the web server goes down, and they wanted a sounding to be able to plan for the mission. I've had the Marine Corps at Quantico ask if they can link to my website during Desert Shield. Got emails from Riyadh asking me questions about things. From the Canadian Navy, which kind of surprised me, is it was down once and they wanted wind information in order to target ordnance. And I go, my boss started claiming that if weather goes down, world peace would have to break out. Yesterday I did a search on the AMS journals for weather.uwio.edu, came up with 49 hits where people acknowledged using that server for significant data to a paper. 25 of them have been within the last 3 years. Research projects, many of you mentioned using the server for classrooms and discussions. There have been a lot of web field projects with the King Air, and usually I'm in the back row waiting for someone to make a decision about where they want to fly, but it's a #1 go-to site for looking at upper level soundings in the research world. And one of our professors came back from a conference once with a whole CD of soundings that this person presented a paper on. The CD was completely filled with soundings from my website, except they went through with digital editing software and edited off the bottom row that said University of Wyoming. I thought that was kind of crummy to do. And so a couple images of things I've been doing. This summer I spent in southern England, in Exeter, which by the way is the home of the Met Office in the UK. While I was there, someone actually sent them a request for one of their sounding stations. They wanted an archive of it. And those guys go, why don't you contact Larry Oolman in Wyoming? But this shows just a Google Earth KML file that I produced after the mission of where we flew. We were over Cornwall, beautiful country down there, all these nice little green fields with sheep in them that have hedgerows around there that the sheep can't get through. Just thoroughly enjoyed southern England. Another product that I produced this is from the Wyoming Cloud Radar. I can't even remember what we were doing, but flying over the Medicine Bow Mountains and extended out. You can see close to the ground here, by this point it's blowing snow coming off the mountain, the little upper level deck. You see this is nice and smooth here. This is nice and smooth. Where the green turns into the browns right over the valley is fairly steep slope, and so the echo rebounds, nice hydraulic jump there. It's separated from the ground, and even the upper level deck you can see going from this nice laminar to turbulent, and so kind of cool visualization. So is IDV going to be able to support mobile CF radial data?
Should be.
Okay.
The radar data are no different, right?
Yeah, except
as long as
except every point is originating from a different point in space.
yeah, we can count on that.
Okay, so NCAR with CSU. CSU also has a national facility. It's a big ground-based radar. NCAR is trying to develop their own cloud radar for the Gulfstream 5, and so those two groups have been trying to come up with a standardized format, which they call CF radial. That'll, as the Hyper Cloud Radar comes online here shortly, I imagine there'll be lots of CF radial data available, and there'll need to be visualization tools, and I think IDV would be an ideal platform for that. And I guess that's the last picture I'm going to show. Any questions from anyone?
Thanks, Larry. What do you use to draw your SQTs? Is it GEMPAC?
It's a modified version of GEMPAC. I mean, most of it is standard GEMPAC, and then the indices that get drawn on the side was a modification I made to the code. I think I also had the capability of tracking parcels into the code. Anything else?
Eric,
Yes.
you mentioned CF radial, and then earlier I think you mentioned another set of conventions you developed.
Well, I didn't actually develop either of them, but I've...
Oh, no, I mean,
Yeah.
I'm sorry, you were working with people
Yeah.
who developed them. And I'm wondering, I think CF radial has been proposed to the CF conventions group, and I don't know whether it's blessed or not yet, but we're trying to figure out in the international conventions world what the next steps might be to help people establish these as international conventions. And I don't know whether those would be good candidates or not.
Well, be honest with you, the RAF Nimbus convention was essentially Chris Webster working in a vacuum, and it's the fact that we're part of the NSF fleet. People can interchange tools to read either one. There is a proposed convention, I think a CF convention for trajectory data that would work for this.
Yeah, I think that was already been adopted.
Yeah, the problem Webster encountered that he had to try to figure out how to do is multi-rate data, and so some observations are reported once per second. Some of the high rate data you might want to do for turbulence calculations or might be 25 hertz data. And so he is trying to figure out how to merge the two. Some of the data you might want to put in there is from a particle spectra probe where you have size ranges with time, number of concentration in each size range. And so he came up with ways to deal with that was probably pre-emphasizing standards and conventions era.
Right, and some of those might not be generalizable, might not be worth the effort to make them more general, but I'm trying to get a picture of what might be coming down the pike, you know.
Yeah, one of the things, since we are not as rich as NCAR found out early on, is that with the net CDF3 having an unlimited dimension, pulling out a variable, most of the variables are pulled out for the entire record.
Yeah.
And so going through and pulling out that information out of each record rather than one block is about a 10-to-1 performance hit. And so it convinced them that at least in the post-processing, make things a limited variable time. And so that would have fixed his problem with multi-rate data, is you could have time 25 or whatever. And I think what the Europeans use might be a better candidate for that, and I suspect we'll switch to that sort of thing at some point in time. So, but I think it pretty well follows trajectory, CF trajectory format, and like I say, the remote sensing is something that's going to be more and more of an issue with LiDARs and radars, airborne ones coming online, and CF radio is a good candidate for that.
Yeah, we have been working with Mike Dixon on
That's
CF radio
right.
a little bit, yeah. And I think the main problem we right now have is the CF radio, they don't have sweep dimension. And in the regular radar, we do have each sweep.
Right.
So that makes it a little tricky to deal. We need to determine, is this radio belong to this sweep or belong to next sweep?
Yeah.
So that is a little different. Yeah.
And our radar is a multi-beam radar. We have 3 or 4 beams going out in different directions, and we produce and so how to store the downward beam versus the upward beam, and how to be able to pull it out and process it is something we haven't looked too much into and see what changes might need to be to the proposed standard for that to work for us.
Maybe separate the beam to different group.
Right.
Nice presentation, Larry. It's great to see that field science and instrumentation is still alive and well in many universities, as more and more students are getting exposed to this computer modeling and taking things off the web and other sources. So students are actually going and taking measurements and collecting and getting their hands dirty with the messiness of actual field and observation data. So, and your work over the years demonstrates the important connection between not just traditional data sources Unidata deals with from weather service or other operational streams, but these very research instruments and field campaigns. And that's a very important connection that Unidata should continue to maintain going forward.
Yeah, for us, it's an exciting new era as that global climate change becomes interesting. We've hired a climate modeler. I mean, that'd be the last thing I ever thought would work at Wyoming, is how to bridge fine-scale observations to community global climate models. And so it's presenting a challenge for my department, an exciting time for us of how to resolve these time spatial differences.
Any other questions for Larry? Okay, thanks again.